This is the 7th video in an 8-part series about my new woodworking workbench, which I fitted with a bench table saw and router table. Today I'm going to show you how to build and use this table saw sled with replaceable adjustable inserts. The workbench has a gap in the bottom of the table saw to store the sled and keep it handy when needed. I've used trailer floor plywood to make the base of the sled. It's a hard and sturdy kind of plywood that's used, as the name suggests, for the interior of industrial vehicles. It has a layer of phenolic resin on both sides. The side that's facing upward in the sled is slip resistant, which allows for better grip on the workpieces. The bottom side is smooth, so the sled will slide better. I've also used the same aluminum profile fence as in the sliding carriage and the router table fence. It's a very versatile profile that will let me use miter track stops and other accessories such as clamps. I've installed a piece of wood acting as an insert to achieve clean cuts at the exit point of the blade. I've screwed it on using neck joint bushings, but you could use any kind of metal washers to avoid damaging the board when replacing the insert. These are the inserts for the base. They're made from HPL with gray melamine, but we could have used MDF or acrylic boards between 5 and 7 millimeters thick. I've machined some grooves to adjust them according to how thick the blade we will use is. I can remove them from the back of the table by taking out the screws. To adjust them, it's best to raise the blade as much as possible and tighten the screws, leaving 0.2 of a millimeter between the insert and the teeth of the blade. It's normal for the blades in these kinds of table saws to vibrate a little when starting or stopping the motor. Here you can see how the blade removes some material from the inserts on startup. I've installed a soft start module in this saw, and even though it's improved, I haven't been able to solve it completely. With these adjustable inserts, I'll be able to adjust them as they wear out or deform by touching the blade. I'm going to make a few cuts to see the sled in action. This sled is ideal for making crosscuts in medium and small size workpieces in a safe and accurate way. I can cut pieces up to 16 millimeters high and 460 millimeters deep. To cut larger workpieces, I have the sliding carriage. The lower inserts make it so that the wood will barely splinter at the exit point of the blade. Now I'm going to try with a much more sensitive board, a piece of chipboard with melamine on both sides. Funnily enough, there's more splintering on the upper side than on the lower one at the exit point. Maybe the blade was too low, but the inserts work like a charm. I've installed some T-track profiles on the base of the sled that will let me hold and cut almost all kinds of workpieces safely. I'll be able to use T-track clamps and hold-down clamps. I can also use hold-down clamps in the aluminum profile fence, but only the ones that have a bolt up to 6 millimeters in diameter. These kinds of T-track clamps are very comfortable when holding relatively high pieces. Besides, they maintain the position once loosened, making them very comfortable for repeated cuts. They'll also allow me to hold pieces so I can cut them at an angle. This sled is very comfortable for these kinds of cuts. You only need to pre-mark the cut and align the cutting lines with the base inserts. The hold-down clamps will be very useful for holding workpieces to the aluminum profile fence and cut rabbets or make these kinds of cuts. It's important to be careful with your hands in these kinds of jobs if the sled doesn't have protection at the exit point of the cut. It wouldn't be a bad idea to make a protector to install at the exit of the cut. It would be easy to install by screwing it to the back plywood piece. These hold-down clamps will be perfect for holding very small workpieces and cut them safely. Just like with the sliding carriage, here we can also make an attachment so that we can extend the miter track stop and cut larger workpieces. We only need to insert it on one of the sides of the aluminum profile fence and lock it at the desired length with a tightening knob. This stop is reversible and can be used both on the left and on the right side of the profile fence. We could even make larger attachments to cut even longer workpieces, and also use the one that I made some days ago for the sliding carriage. Another interesting possibility of this lead is to use it with a dado blade to make rabbets and all sorts of wooden workpieces. You only need to adjust the inserts of the base to the thickness of the blade and change the aluminum profile fence's wooden insert. These types of blades are normally used to cut grooves. With this setup, it's 6.3 millimeters thick. To use it as a fence insert, I can use any kind of board that's 15 millimeters thick. It will allow me to cut, for example, wooden tenons. It will also allow me to make box joints, both with the same dado blade or with a normal blade. Making the insert is easy. You only need to glue a piece of wood as a stop and place it away from the cutting line, the same distance as the thickness of the blade we'll be using. The height of the blade must be the same as the thickness of the wooden pieces. I'm going to run a few tests to show off the process and the end result. I think it's a little dangerous to make these sorts of joints this way, and I'm thinking of making a jig to mount on the sled and make box joints in a faster and safer way. Now I'll show you how to make the table saw sled. I'll start by cutting its base. I'll mark the positions of all the holes needed for the screws and drill them with a column drill. The next step is to cut the back part of the sled. I mark the cuts following the plans and finish machining it with a bend saw and a sanding disc. I'll use the piece I've just machined to mark the other 9mm plywood piece. Once it's cut, I glue the two pieces together. It's time to machine the front of the sled. I've cut it to size and, like earlier, I'll pre-mark and drill all the necessary holes. Once machined, I can mount the sled by screwing the base and the front and back together. I'll use the holes I'd already drilled as a guide to drill the base. Now on to the central cut in the sled. First, we should make sure if the blades adjusted to the miter channels and bench table saw fence. I lock the fence at the required measurements and start cutting. This is when we can leave the sled centered in the table saw or off-center. Once the cut has been made, I mark the position of each piece and remove the sled to continue machining. First, I'll make the rabbet for the base insert. I'll do this little by little, making sure I don't cut too deep. It's important that this rabbet is exactly as thick as the material we'll be using for the insert. With the table saw in several runs, I'll cut the grooves to insert the T-track profiles. I'll finish the rabbet with the router table. I'm also going to mark and machine the cut necessary for the back piece of the sled. It will let me place and remove the inserts easily. I'm going to drill holes for the threaded inserts. I'll screw them to the board with a column drill to ensure they're square. It's time to cut the aluminum profile fence to size. I'll also cut the center of the profile so that I can place the wooden insert. I'll use a miter saw and a blade to cut aluminum. I'll finish the cut with an oscillating multi-tool and a file. Before mounting the sled again, I'll drill holes for the joint bushings. I'll also cut the T-track profile so that I can screw them to the base of the sled. I also cut to size the screws that will let me hold the aluminum profile fence to the base of the sled. Even though it's not necessary to use them, I'm also going to place the screws that go on the underside of the sled. It's time to cut the sliders that will direct the sliding movement of the sled. I'll cut some pieces of 8mm HPL I have in my workshop. I make sure they're the right size by inserting them in the miter channels of the bench table saw. I mark and drill all the required holes with a column drill. I'm going to insert on the miter channels other pieces of the same HPL acting as spacers, and with a little cyanoacrylate, I glue the sliders to the bottom of the sled. I've used the fence to leave the sled centered with a table saw top and square with a saw blade. Once the glue is dry, I remove the sled and place all of the screws using a self-centering drill bit. I cut the inserts for the sled from another piece of HPL. I'll use my 3D router to machine the adjustment grooves. I prepared a jig with a mark in the center of the milling to make this process easier. First, I'll cut a through groove with a 6mm bit. Then another one halfway down with a 16mm bit. These grooves could have been made with a handheld router and jigs. I cut the bolts to size and make sure everything's correct by placing the inserts on the base of the sled. For the exit wooden insert, I'm going to cut 4 pieces so I can have replacements. I cut them to size and make sure they fit the gap in the aluminum profile fence. With a bit, I mark the positions of the holes for the screws and drill them with a column drill. Now I can finish machining the central cut in the table. I'll do it in several runs, for every 10mm approximately. After measuring a small piece of plywood, I use it as a reference to glue on the measuring tape to the aluminum profile fence. I'm going to make the extendable part of the fence. First, I'll cut the steel pipes to size. I'll make some holes in the small profile with a bit 0.5 millimeters less wide than the bolt I'll be using. I also use the column drill to thread the holes. I'm also going to drill a hole that will allow me to lock this extendable fence as required. I could have done this earlier and it probably would have been easier. I'm going to try to remedy this with a wooden jig that helps me get straight holes. I'm also going to need to thread the wood and the profile. Finally, I'm going to cut and screw some plywood strips below the bench table saw to make it possible to store this lead. In the plans, I used two 18mm plywood strips, but I had a 15mm piece in my shop that will let me get away without making a rabbit to achieve the required measurements. I screw on two aluminum plates in the back that will act as stops and screw the plywood strips to the bench. There's one last consideration I'd like to talk about. The blade in these kinds of saws isn't usually at the center of the work table. In this case, there's a 10mm difference. The design of the plans has a central cut right in the center of the base. By using it in this saw, the sled would be slightly off-center to one of the sides, more or less like this. I've modified the design on the fly while I was making it so that the sled would be centered with the work table. Both systems are perfectly valid. That's all for today. In a few days I'll post a new video showing everything this mobile workbench can offer. I'll also show how to make the drawers and any other missing accessories. See you soon.